Hello, this is AI in Agriculture, one idea a day. And we actually have subchapter one idea a night, because as you can see again, I'm recording it in quite late time. So sorry about this, all the light issues. But we will speak about some plant which also likes good light. And the plant is called cannabis. In cannabis sativa, we have two types of cannabis. So it's hemp, or officially it's called industrial hemp plants. And we have that type of cannabis which is used for medicinal and recreational purposes. And I will not tell you how it spells, because I'm sure my video will be just banned by YouTube and other channels where I promote it. So today I also published one of my regular newsletters in LinkedIn, so let's just start with this point. Before we will go into the depths of cultivation and using smart technologies for improvement of cannabis research and cannabis farming, just clarification that basically the methods which we are discussing today, they are pretty relevant for both types. So my newsletter today has three main research papers which I found, and I believe they're interesting because they try to implement machine learning, computer vision, hyperspectral imagery for yeah, I have already read about the same approaches for different crops, but for cannabis is quite unique and new. And just going a bit back, getting the cannabis and its different legal status, it's all about the different amount of tetrahydrocannabinol. And if we speak about industrial cannabis, it's below 0.3%, and if it's above, then it's basically that type of cannabis. But let's focus on the application of innovative technologies. And again, we will focus today on the first research paper, and maybe tomorrow or the day after tomorrow we'll look at the second one and third. So the first research paper has been published by the nice, energetic and young, talented researchers from Spain. And they had this idea to do the constant monitoring of cannabis plants in the greenhouse. And this is very interesting idea because it's the first step for non-human involvement in monitoring of plant growth and plant phenotyping. So the team, and here you can see they have collected pretty nice footage of growth. So they have what they have done, they have created the system which was monitoring the plants. So they have three cameras, and then each camera, USB camera, was attached to the edge processing device, let's call it like that, but in fact it was Raspberry Pi, like this one. And then they did this monitoring also using sensors. So they were collecting the temperature, humidity, and other aspects of environmental conditions to understand the change and to see the change, as well as they were capturing the photos of plants. So each camera had 4 plants. So we had like 3 cameras for plants, 12 plants in total. And they did this nice, you see, nice collecting data. And they also deployed very popular computer vision algorithm YOLO. You look only once, it's translated like that. And YOLO, with every version, YOLO is more and more stronger in terms of its work and what can be done with YOLO. So what is good regarding their research at all, as I mentioned, it's just revolutionary because they done it for cannabis, And yes, there were some other research papers. They have cited them in the introductory part of their research. At the same time, what is good that they discovered the challenges, the weak points of this approach. And they nicely explain them. You can read the research paper. I cited it here, and also I will put the link below the video. But good thing is that now we know that, for example, yes, and again, we saw this in other type of crops and camera monitoring, but again, it now it's confirmed for cannabis as well, that if you have the daylight, and then on windy or not windy, in rainy days and days without sun, when you're using LED lights, then it creates inconsistency in monitoring. And then it's just very difficult to compare these numbers which you are getting, for example, regarding the greenness. And this is the painful point, because, for example, in our PTOL Pro mobile application, we also have the greenness greenness module, which can give the index for greenness called a dark green color index. But again, we are using this type of calibrating plates. I will show you in a second. Here you see we have these two circles, so they are standardizing at least and giving, when you are already taking the image and you are using calibrating plate, you leave next to these two circles, at least when the model inside the smartphone is processing this image, they have some benchmark of green color. And this is one of the strongest challenges which the team has discovered during their work with cannabis, that due to inconsistent light, it's not the easiest thing to recognize the chlorosis on early stage, specifically if we speak about the growing plant and the number of the amount of vegetation is growing, and that's why the pixels which are captured are growing as well. At the same time, inconsistent light made it less visible for the camera. Also, the second thing, what was interesting, that again, we have discovered it, but in orchards, not just in greenhouses, and we were speaking about the apple trees. But the same problem is with apple trees and blueberry plants, because even blueberry plants even more problematic, because the berries goes inside the bush as well, the plant. And the same thing regarding cannabis, it's 3D plant, not 2D. And the USB cameras, they are capturing basically 2D image, and then it's easier to process and to work with this imagery. And again, it's cheaper, but the problem is that it's not demonstrating the full status of the plant. And also, one more thing, they mentioned that this stable camera, which is not moving, permanently placed, it creates some challenges on the later stage, firstly, because the plant is growing in its size, and then on labeling stage, it requires, the camera was not capturing like full plant, and the bounding box was not fully capturing all the plant. And also, again, this permanent position of camera is directly linked with the 3D structure of plant, so that you cannot monitor the plant properly from all the sides, and this may bring not pleasant surprises when there is some early stage of either disease or some other maybe nutrition deficiency or something which should be captured, but it will not be captured because it's on the other side where you don't have camera. And if you decide to put two cameras on both sides, then another challenge is about money, because you can understand that these thing costs 100 pounds, then you have a camera which costs at least a few dozens of dollars or pounds, depends on your currency. But I mean that it's still a little bit a lot to do, but and a lot to spend on. But good thing is that the team has used the free open source software for some of the parts of the work, and this is again a bit challenge because you still need some basic understanding of how the computer vision works, how the machine learning works, how all this ecosystem of processing of data works, and then only you will be able to deploy the system, and then it works zero per month. You can work for free and don't pay anyone anything. You can have your own device which is processing, and so you just logged in for your own informational system, and you are not required to send your data either to cloud or to some other third party provider. But again, as I mentioned, it's all about niche knowledge. Yes, regarding the good thing, what I want to say that this research is nice and a good first step for understanding how the monitoring, real-time monitoring, because this monitoring was providing the environmental data with frequency like 15 or 20 minutes, and then the photos were sent a slightly longer period, but again it was good example how to link the response of plant to the environmental conditions, and how to support this imagery with some numbers about the realistic situation, what's going on in the greenhouse. And I think it's the end of today's one idea a day, one idea an evening or a night, depending on where you are now. So thank you so much for your time, and I hope this was useful for you. And please let me know about any questions or comments. Do you have any? Please put them down this video, and it will help to move on further to the next ideas and next chapters of one idea a day. Thank you so much, and see you tomorrow.